Welcome to this comprehensive tutorial for beginner Unity 3D developers, where we'll dive deep into the powerful world of Unity coroutine wait types. Coroutines are a fundamental feature in Unity, allowing you to execute code over multiple frames without blocking the main thread, which is crucial for maintaining a smooth and responsive game. At their core, coroutines are functions that can pause their execution at specific points using yield return statements and then resume later, allowing other tasks to run in the interim. Think of it like a chef preparing multiple dishes. Instead of waiting for one dish to completely finish before starting the next, they can chop vegetables for one, put another in the oven, and then return to the first, managing tasks concurrently. The primary benefit of coroutines is preventing the main thread from becoming blocked. If the main thread is busy with a long operation, your game will freeze, leading to a poor user experience. Coroutines help you avoid this by allowing you to spread out intensive operations over several frames, ensuring your animations remain fluid and your user interface stays responsive. They are also incredibly useful for managing complex sequences of events, such as a series of tutorial steps, enemy attack patterns, or timed game mechanics. Today, we'll focus on three essential wait types that dictate when a coroutine pauses and resumes. Wait for seconds, wait until, and wait for end of frame. We'll explore each of these with detailed explanations, code examples in Visual Studio, and live demonstrations within the Unity editor. Let's begin our journey by understanding wait for seconds, a fundamental wait type for introducing time-based delays in your coroutines. Wait for seconds pauses the coroutine's execution for a precise, specified amount of time, measured in seconds, making it perfect for simple delays like blinking lights or cooldown timers. It's crucial to understand that wait for seconds is scaled by time.timescale. This means if you set time.timescale to 0, effectively pausing your game, any wait for seconds calls will also pause. If you need a pause that is unaffected by time.timescale, perhaps for UI elements during a paused game, you should use wait for seconds real-time instead. The syntax for wait for seconds is straightforward. Yield return new wait for seconds, where seconds is a float value defining the duration of a delay. Let's create a practical example, a blinking object. Begin by setting up a simple scene in Unity with a game object, such as a cube or sphere, which will make blink. Next, create a new C# script in your project window. Name it blinking object, and then attach this script to your cube game object. Open the blinking object script in Visual Studio. We'll declare a public blink interval float to control the timing and a private renderer component to access the object's visual properties. In the start method, we'll initialize our rend variable by getting the renderer component attached to this game object, and then we'll start our blink coroutine. Now, let's define the IEnumerator blink method. This will be our coroutine, designed to run continuously, so we'll place its logic inside a while loop. Inside the loop, we first set rend.enabled equals true to make the object visible, then yield return new wait for seconds, pauses the coroutine for our specified duration. After the pause, we set rend.enabled equals false to hide the object, followed by another yield return new wait for seconds to pause again before the next blink cycle. This continuous loop of enabling, waiting, disabling, and waiting creates the persistent blinking effect, with each yield return statement acting as a controlled pause. Save your script and return to the Unity editor. Select your cube game object and observe its inspector panel. Now, run the scene. You'll immediately see your cube game object repeatedly appearing and disappearing, demonstrating the wait for seconds functionality in action. You can easily adjust the blink interval value directly in the inspector while the game is running to see how it changes the blinking speed in real time. This simple example clearly illustrates how wait for seconds provides precise, time-based control over your coroutine's execution flow. Next, we'll explore wait until, a powerful wait type that pauses a coroutine until a specific condition becomes true. Wait until is incredibly flexible, allowing you to pause execution until a player presses a key, a variable reaches a certain value, or any other Boolean condition is met. It utilizes a system, func bool delegate, which is essentially a small, anonymous method that returns a Boolean value, defining the condition to be checked. The syntax is yield return new wait until, where predicate is the function or lambda expression that evaluates to true or false. For our practical example, we'll create a coroutine that waits until the space key is pressed before continuing its execution. Start by creating a new C-sharp script in Unity. Name it Wait Until Example and attach it to any game object in your scene. Open Wait Until Example in Visual Studio. We'll declare a private Boolean variable is ready initialized to false, which will serve as our condition.
In the start method, we simply initiate our example coroutine, which will contain the wait until logic.
The update method will continuously check for user input. If input.getKeyDown detects a space key press, we set isReady to true. Now, let's define our IEnumerator example coroutine. It first logs coroutine started to the console, indicating its initiation. Then, the crucial line, yield return new wait until. This pauses the coroutine right here until our isReady variable becomes true. Once isReady is true, the coroutine automatically resumes, and we log, isReady is now true. Coroutine continues to confirm its continuation. Save your script and return to the Unity editor. Ensure the wait until example script is attached to a game object. Run the scene and immediately observe the console window. You'll see coroutine started appear, but nothing else. Now, press the space key on your keyboard. Instantly, isReady is now true. Coroutine continues will appear in the console. This clearly demonstrates how wait until effectively pauses your coroutine until a specific dynamic condition is met, providing precise control over event-driven sequences. You could use wait until for various scenarios, such as waiting for an animation to complete, a network request to finish, or a player to reach a certain score. Our final wait type is wait for end of frame, which offers a unique pausing mechanism crucial for tasks that depend on the entire frame being rendered. Wait for end of frame pauses the coroutine's execution until the very end of the current frame, specifically after all cameras and GUI elements have finished rendering. This makes it indispensable for tasks that require the scene to be fully drawn and presented, such as taking accurate screenshots, reading pixel data from the screen, or performing post-rendering effects. The syntax for wait for end of frame is the simplest of the three. Yield return new wait for end of frame, with no parameters required. For our practical example, we'll implement a function to take a screenshot of the game view. Create a new C-sharp script called screenshot example and attach it to any game object. Open screenshot example in Visual Studio. In the start method, we'll simply initiate our take screenshot coroutine. Our take screenshot coroutine begins with yield return new wait for end of frame. This ensures that when the code proceeds, the entire frame has been fully rendered. After the wait, we create a new texture 2D with the screen's dimensions, then read pixels from the screen into this texture and apply the changes. Finally, we encode the texture data to a PNG format, destroy the temporary texture 2D to free up memory, and save the resulting bytes to a file named screenshot.png in your project's root folder. Save your script and run the scene in Unity. The game will start, and the screenshot will be taken automatically. Now, navigate to your Unity project folder. You'll find a new screenshot.png file captured precisely at the end of the first frame, showcasing your game exactly as it appeared. This demonstrates the precision of wait for end of frame for tasks requiring a fully rendered visual state. To summarize, wait for seconds is your go-to for simple, time-based delays, pausing execution for a fixed duration. Wait until provides flexible control, pausing your coroutine until a specific, dynamic condition becomes true, perfect for event-driven logic. And wait for end of frame is essential for tasks that must occur after all rendering is complete, ensuring you're working with the final visual output. For performance optimization, especially when using wait for seconds repeatedly, consider caching the wait for seconds instance. Instead of creating a new wait for seconds object every time you need a delay, which can generate garbage and impact performance, create it once and reuse it. This simple caching technique can significantly reduce garbage collection, overhead, and performance-critical sections of your code. Finally, always be mindful of overall coroutine performance. Running too many coroutines simultaneously, especially complex ones, can still impact your game's frame rate. Consider using object pooling for frequently used coroutines or implementing other optimization techniques to maintain a smooth and efficient user experience. By mastering these coroutine weight types and applying performance best practices, you'll be well equipped to create dynamic, responsive, and highly optimized Unity applications.